Welcome everyone to this lecture on the Pandas Series object. A series is a data structure in Pandas that holds an array of information or data along with a named index. The named index is really the aspect of a Pandas series that differentiates this from a simple NumPy array that we learned about in the previous section. As a formal definition of what a Pandas series is, it's a one-dimensional ND array with axes labels. So let's actually show you realistically what that means. So we already know that a NumPy array has a numeric index, which means if I have a NumPy array storing, for example, the years of independence of countries in the data, then I have a numeric index that's associated with that. So if I wanted to grab, for example, the year 1776, then I say, go ahead and index item 0 off this NumPy array. Now, that's all well and good, but the problem is that it'd actually be a lot more useful as far as the data is concerned, to have it associated with a string label. Because right now I have to actually memorize the positions of the years instead of memorizing or knowing the association I want with them. And so what a Pandas series allows us to do is supplement that index with a labeled index. So the Pandas series essentially adds on a labeled index that can be strings or names or really anything you want here. And you'll notice now I'll be able to grab information off this Pandas series based off the labeled index, which makes it a lot easier to grab data in an informative way. So I can say, go ahead and grab the series at index USA, and it would return back 1776. That's a lot easier to use than having to memorize those index positions. And it's more in line with what real-world data looks like. Something I want to clarify, however, is that the data is still numerically organized. And essentially, you can think of a Pandas series as just holding a NumPy array internally and then adding on that named index. So I can actually grab information through a numeric index call or this labeled index call within a Pandas series. So essentially now I get the best of both worlds. And it's still very computationally efficient to store data in this format. So you'll have both access to a numeric index and, more importantly, this supplemented labeled index. So what we're going to do is we're going to explore the various ways to create this Pandas series object. And we'll also learn about some key properties and operations. So let's head over to the Jupyter Notebook and explore a Pandas series. Okay, here I am at a new Jupyter Notebook. First thing I want to do is import NumPy as NP in case I want to create some data. And I'm also going to import Pandas as PD. And import Pandas as PD is the main convention used for importing Pandas objects. And what we're going to be working with is the Pandas series object. And you can check out the documentation online for more information about a Pandas series. Or what's really useful is if you just call help on pd.series, note it's a capital S there, and hit Shift Enter, it's actually going to display the documentation here for you. And you'll notice it's very comprehensive. So it shows you all the methods available on a series. And if you keep scrolling down, it'll eventually actually show you examples. So here we can see examples of creating a series, how it deals with missing data, and so on. So there's a ton of information here. Granted, if you're this far down in this help function, I would just say go to the online documentation instead. It's going to be a little easier to read there. But it's always available for you here within an IDE by just calling Python's help on the Pandas series object. Let me go ahead and comment this out and continue. So if we say pd.series after importing Pandas as PD and do Shift Enter here, we have the documentation string or the signature here for the main ideas of what we need to pass in to a Pandas series. Lots of things like data, index, data type, name, and so on. But the main things we have to be concerned with here is data and then index. And that's really what's going to add on the supplemental index to the data, which is stored as a NumPy array within the series. So in fact, let's create real quick 2 objects. We'll create them as Python lists, just normal Python lists. We're going to create an index, USA, Canada, and let's say Mexico. So it's in line with what we're showing in the slides. And then we'll say my data is equal to, let's say their years of independence, 1776, 1867, and then 1821. And so what I'm going to do is create a series object by saying my SER, my series, is equal to pd.series. And we're going to say the data is equal to data, or my data actually. So we're passing in right now just data as a normal Python list. And if we run this and essentially ask for what does my series look like, you'll notice that Pandas immediately reports back your data organized internally. And internally, it's essentially converting this Python list to a NumPy array held inside as a Pandas series. So if you check the type of this object, it's going to report back that it's a Pandas series now. So it says pandas.core series. And you'll notice that automatically it's going to show you the default numeric index. But as we just explored within Pandas series, it also takes in this index parameter. So now let's not just provide data, but let's also provide index. So we'll say index is equal to, and now I'm going to pass in these string codes here because it's going to be a lot easier to look up information based off the string that I know, such as USA, instead of having to memorize, position 0 for 1776. So I'll say index is equal to my index. Run that again to redefine the series object. And now we can see that the index is this labeled string index, which means I can actually grab information off of this almost as if it was a dictionary. So we'll say my series, and then I can say at 0, and it'll return 1776, or I can say my series at USA, and it also returns 1776. So you'll notice that the series object now retains both this numeric index by location and this labeled index, which is what we're going to be using throughout the course. Typically, we're going to have a labeled index, which is going to be easier to read than just searching for strings numerically. One more thing I want to point out is I'm being explicit here as far as what the arguments represent, such as data equals and index equal. Obviously, as long as I provide them in the correct order, that's not necessary. I can just say my data comes first, then my index comes second, and if I rerun these, it's the same thing. So typically, you're not going to be so explicit as far as the arguments are concerned, as long as you pass them in the correct order. I'm just doing it so it's very clear what the data is and what the index is. Okay, so that's one way of creating a series, essentially defining an index or defining data. And we saw that at a minimum, all we need to define is the data. And Pandas will, on its own, create that default index of 0, 1, 2, all the way to however many entries you have. We can also create a series from a dictionary. So let's go ahead and create a dictionary. We'll say ages is equal to, and what I'm going to do here is just create a couple names, such as Sam. Let's say Sam is 5 years old. We'll say Frank. Say Frank is 10 years old. And we'll say these are the ages of dogs or something. We'll say Spike is 7 years old. And what's interesting here is what I can do is if I have a dictionary like this, I can easily pass it into Pandas series and say, this is just my data. And Pandas is smart enough to make these dictionary keys the index and make the values the array data. So if I run pandas.series, what it's going to do is it's going to automatically transform this into a series. And that's really useful because as we learn about more libraries within Python, a lot of times they return the information in the form of a dictionary. So it really helps to easily organize that information, just passing it into a Pandas series object. All right, so we'll conclude this lecture on the very basics of series, and in the next lecture, we'll continue on by showing you various operations you can perform with a Pandas series object. The main thing you should have gotten out of this lecture is that a Pandas series will go ahead and take in data, and if you want, it'll go ahead and take in a labeled index. And if you pass in a dictionary, it will automatically transform that into a labeled index with corresponding values. As a quick note, the notebook that we're referring to is the first notebook here and under the Pandas folder. It's called 00-series. And if you open up that notebook, you can go ahead and scroll down to where we begin discussing the key ideas of a series, such as a named index. And what I'm going to do is I'm going to copy the input for cell number 32 in that notebook, which is essentially just two dictionaries. And these dictionaries are essentially imaginary sales data for the first quarter of a company and the second quarter of a company. So it's just to easily create two series objects from a dictionary. Save ourselves a little bit of typing by just copying and pasting this from the lecture notebook. And then what we're going to do here is we're going to convert this into a Pandas series. As we discussed earlier, I can just create a variable, name, and then say PD series, and we'll pass in this dictionary Q1. And let's say sales Q2 is equal to pd.series Q2. Again, remember it's capital S there. And so what I have here for sales Q1 is this Pandas series where I have a labeled index of a country, Japan, China, India, USA, and then let's say the sales values for those particular countries in, let's say, quarter 1. And if we check out quarter 2, sales Q2, then I have sales for the second quarter of this imaginary company, Brazil, China, India, USA. So again, a couple of things to notice here is I can, as before, grab items based off the label index. So I can say, okay, sales Q1, what's going on, let's say for the country of Japan. I run this and it tells me my sales for Q1 were $80. Or I can also do this based off a numeric location. So if I somehow knew I wanted the very first item in that series, I would say 0 and returns back 80. Obviously, it's a lot more clear if we start using that labeled index, what 80 actually represents here. So I would encourage you to set up your data in a way where if you're doing some sort of grabbing of data, you try to use a named index. So it's clear when you review your code or send your code to someone else, they can easily read it. This is a lot more readable than just passing it 0. And something to keep in mind, a super common mistake is accidentally passing in the wrong key here. So the key has to be exactly what the key is inside the actual series. So if you were to lowercase this to Japan, it's going to say there's a key error because it's key sensitive or it's case sensitive. So you'll notice here lowercase j doesn't work, or even if you do something, which is a really common error of accidentally having, for example, an extra space. So if we say Japan, accidentally put an extra space there, it'll say key error Japan. So just keep that in mind. If you actually want to see what keys are available to you inside a series, because maybe you're having trouble actually finding it, you can say sales Q1 or whatever the name of your series is, and say keys, open and close parentheses, and then it's actually going to return back this index object, which is your index objects in order. So we can see that here. Okay. So this was one really easy way of finding out, oh, what's the exact string for whatever I'm looking for? Okay. So we know how to grab the keys and we know how to grab stuff based off the keys. Let's go ahead and discuss the very basics of operations between two series. So what's really nice about Pandas series objects is because they're built off a NumPy array, then we can actually perform broadcasted operations on them. So recall if I have a list such as 1, 2, and if I were to try to multiply everything in that list by 2, we already know something like this doesn't work. Because what it's going to do is it's actually going to double up that list, when really what I want to do is multiply each item in that list by 2. However, we do know that if it's a NumPy array, this operation gets broadcasted, and then it gives us the results we expected, 2 and 4. And luckily, since a Pandas series is built off a NumPy array, then the same happens here. If I say sales Q1, it's going to report it back by the broadcasted operation, which means we can do stuff like start easily getting things. Maybe we want to divide by 100 or something like that to get it into some sort of percentage format. And we can easily do that within a Pandas series itself. So you can broadcast these sort of operations. And what's nice is because we have a labeled index, when we perform operations between two series, it's actually going to take the labeled index into account. So what do I actually mean by that? You see that I have sales Q1, Japan, China, India, and USA. And if we take a look at this company's second quarter sales, you'll notice it says Brazil, China, India, USA. So what's actually happening here is we have information on Japan in Q1, but not in Q2. Instead, it got replaced by Brazil. So what happens if I'm trying to calculate my total sales for the first half of the year? Essentially, I want to say sales Q1 plus sales Q2. Well, if I say sales Q1 plus sales Q2, and I run this, by default, Pandas is going to be smart enough and match things up based off their labeled index. However, it's technically not smart enough to know what it should do in the case of the labeled indices not being present in both series or the multiple series you're adding up together. So instead of replacing it with a value, it will actually show you not a number and not a number for Japan. And this is actually a good way of Pandas essentially telling you, hey, Brazil and Japan are not present in both these series. Now let's say you, as the user, actually know that to be the case, and you want to fill in some value by default when it's not present in the series. Essentially, for example, you want Brazil in Q2 to be 100, and in theory, you want Brazil in Q1 to be 0. That way, this actually shows up as 100 when you add them together, and Japan shows up as 80 when you add them together. So while this is nice, that Pandas warns you, hey, Brazil and Japan aren't present in both these series, let's say after adjusting our evaluation, we say, that's okay, I need them to be filled in of some value. Well, to do that, we say sales, Q1, and then what we're going to do is we call the add method on it. So we no longer use Python's base operators. Instead, we're going to have to call add. And if you do tab here, there's going to be a list of operations. So for example, if you wanted to do some sort of multiplication, it's going to be MUL or multiply. So keep that in mind. If you wanted to do division in this sort of format, it's going to be div or divide. You'll notice there's kind of two names here which do the same thing. So one's a little shorter than the other, but we want to add them. So I want to say sales Q1 added to the series sales Q2. So in parentheses with this method call, it says, hey, what's the other thing you want to add in here? And then it also takes in a fill value. So we'll say sales Q2, go ahead and add it. And then if we see what does that actual fill value represent, I scroll down here and it says the fill value is what you should fill in for existing missing values. So essentially, what are you going to fill in for Brazil and Japan if they're not present in both series? And in this case, a reasonable fill value is 0, since we made 0 sales for whatever quarter they're not present in. And now I can say fill value is 0. I run this and I get back the results I want. I see Brazil is now 100 and Japan is 80. The last thing I want to point out here before we finish off this lecture is you'll notice that my original values were in integers. In general, as soon as you start doing numeric computations with any objects within Pandas, it's going to quickly convert them into floating point numbers. So it's just something to keep in mind. You can always specify the data type or change the data type of a Pandas series as you go along. In fact, it's one of its attributes you can access by saying dtype. And the original one you can see is integer 64. But if I say first half is equal to sales Q1 added to sales Q2, and then check the integer type, or excuse me, the data type there. So first half dtype, you'll notice now it's a floating point number. It's just something to keep in mind. Typically for our operations, we're not going to be concerned with things being transformed from an integer to a float because the math is still going to work out to our favor. It doesn't matter if we have 1 or 1.0. So throughout the course, we're not going to worry about this. But if you have a situation where you need them to be integers, you can always either round them off using np.round or pandas round, or you can just specify or hard code the data type in your operations to be whatever you're looking for, 64-bit integer or 64-bit float and so on. And in fact, if you look back up to pd.series, or if we just call it here, pd.series, there's data index and there's also data type. So you can actually specify the data type for this series. And if you want, you can also name the series, which is just going to be a name that's kind of this high-level label for this series overall. All right. So that's the very basics of a Pandas series. Main thing to note here is that when you perform operations with two series, Pandas is going to be smart enough to understand that they're labeled and that they should perform the operation on the labels. However, if you have a special case where you don't want null values and instead you want them filled in with something, you'll have to call these special method calls.